This video is a continuation of video tutorials on civil engineering materials lab experiments. I am Usman Javed. I will be teaching you different lab experiments of civil engineering materials. This is the content which I will be covering. In first section, we will cover the cement properties like fineness, its consistency, setting time, and its soundness. Secondly, we have an sand or a fine aggregate. We'll perform certain tests on fine aggregate, including moisture content, water absorption, bulk density, according to ASTM standards, specified standards. And then, after in sand, we will perform gradation and fineness modulus of a sand, how the particles of a sand is graded based on their percentage passing on a different sieves, as specified in the ASTM C33 specification. Then we will study the bulking of sand, how bulking affect the sand and concrete constituents, and finally the concrete mix. Then after sand, we will study the coarse aggregates. Coarse aggregates includes obviously the coarse aggregate, uh, the particle size which is above the sieve number 4 or 4.75 millimeter sieve will be treated as a coarse aggregate. We'll discuss its gradation, fineness modulus, and specific gravity and water absorption characteristics. And lastly, we will discuss the supplementary cementitious materials, which are nowadays very prime constituent in concrete, in modern concrete, which is used to enhance the properties of a concrete. Like we have a fly ash, like we have a ground granulated blast furnace slag or silica fume as an cement additive in concrete. So, in order to have the concrete properties enhanced in modern concrete industry, uh, we uh, we need to have all these materials in a concrete mix. So, in order to study their properties, we'll use to find the specific gravities using the Le-Chatelier flask or by the standard method by which you find the specific gravity of a cement. Then you will find the loss on ignition, which is very important factor, which is very important property while defining its pozzolanic characteristics. According to ASTM C618 as specified, it must have the supplementary cementitious material must have a loss on ignition value less than 6%. So we have to find the loss on ignition value in order to specify our material is it pozzolanic or not based on their chemical characteristics. So then we'll discuss the X-ray diffraction, which is something about the microscopic crystallographic property of a supplementary cementitious material, which is very important to characterize either the material is amorphous or crystalline, basically amorphous and crystallinity uh, on based on its reactivity or inertness. Like we have a sand with a 90 more than 90% of a silica, but the sand is too much crystalline. It is not amorphous. It's not reactive. It's inert. So on the other hand, you have a silica fume, have one which has around more than 95% of a silica, but that silica is too much reactive. It it reacts with the other constituent like other alkalis, also calcium hydroxide, to form a pozzolanic hydrates. So inertness is basically the important factor to define the your supplementary cementitious material. Then you have an X-ray fluorescence test in which you study the oxide composition of your sample specimen of a supplementary cementitious material in which you have different percentage oxides of a sample after conducting this test. Then lastly the chemical characteristic test of a supplementary cementitious material, which tells us about the chemical reactivity of that material, either it's fly ash, GGBFS, or silica film. How much it is reactive, we can find out by this test. So this test is basically the acid-base titration we'll discuss in detail in these lectures.